Okay, we're back, and we're going to do an example here with a quadratic formula. And just to bring geometry into it, uh, this is an example of a rectangle, and we call this the golden rectangle. And the reason we call it the golden rectangle is it has kind of a special property that when you take this rectangle and you cut a square that has the same length as the width off, then you're left with this other rectangle on this half. And this rectangle has the same similarity to the original rectangle. So if I were to turn that over and blow it up, it would have the same kind of ratio of the sides, or it would be a similar rectangle to the original rectangle. So I want to find out what is the value of the side length that would make this thing work. So let's say this is x, then this would also be x. And let's just, I could pick any number, but I'm just going to pick 1 just to start with a unit length right here. So the length of this is x plus 1, and the length of this is x. So the ratio of the sides would be x to x plus 1. Okay, and then I need it to be similar to this rectangle. So if this is 1 and this is also x, right? So the sides that are similar would be 1 and x, right? So these two should be proportional to each other. Alright, so what I want to do is solve for x. So I multiply x times x, or I could just multiply both sides by x. So I get x squared on top. And then I'm also going to multiply both sides by x plus 1. So the x's cancel, the x plus 1's cancel, and I get x squared on this side, and I get 1 times x plus 1, which is just x plus 1. So we have this this relationship of the square of the side length is equal to 1 plus the side length. Okay, so I'm going to solve this quadratic equation using the quadratic formula. So I'm going to put everything on the side so I get this standard form, ax squared plus bx plus c equals 0. So I'm going to subtract x from both sides and subtract 1 from both sides. So I get x squared minus x minus 1 equals 0. So now what I want to do is list my my coefficients. So I have a, b, and c. So a equals, the coefficient here is actually a 1. You don't see it there, but that's the multiplier on x squared is just a 1. And then the multiplier on the x is actually, I want it to be plus, so it's actually minus 1. So b is minus 1, and c is also minus 1, negative 1. Alright, so I'm ready to plug this into the quadratic formula that we came up with. So x is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. So I'm going to fill in all these values. So what I like to do is put little parenthesis placeholders for all of these so that I get all my signs correct. And I recommend that you do that as well, that you put placeholders in first and then fill them in. So 4a times c over 2 times a. Okay. So I'm going to fill in all these gaps. So negative b is negative negative 1. B squared is negative 1 squared. 4ac is 1 and negative 1. And a is 1 down here, 2a. Alright, so now I can simplify this a little bit. So negative 1 squared is positive 1. So 1 minus 4 times 1 is minus 4, and negative 4 times negative 1 is positive 4. So under the square root, I'm going to have 1 plus 4 in here. So let's just simplify this a little bit. So negative negative 1 is positive 1, plus or minus the square root of 1 plus 4 is 5, over 2 times 1 is 2. So this is my solution. There's two solutions, 1 plus the square root of 5 over 2 and 1 minus the square root of 5 over 2. In the geometric problem, I believe you can leave out the negative because you can't have a negative side length. But that is a solution to this quadratic equation. x squared equals x plus 1.